In this video, we will discuss module number 3. The module name is linear algebra. In this topic, we will discuss the subtopic of diagonalization of the square matrix. The diagonal matrix. So we'll discuss the what's the diagonal matrix and how to find the diagonal matrix by the given matrix. Okay. So first we'll discuss what is meant by diagonal matrix. So a diagonalization of a square matrix. If A is a square matrix of order n having n linearly independent eigenvectors, then there exists an nth order square matrix P such that P inverse into A into P is called diagonal matrix. So P inverse of AP is called diagonal matrix, where P is called model matrix. So this is the definition of diagonal matrix. So already I explained the introduction, the first video, what is meant by diagonal matrix. So diagonal matrix is nothing, it contains only for the diagonal element. That meaning is it's having a upper triangular matrix and also a lower triangular matrix. So that is called diagonal matrix. That means the diagonal element, diagonal, this is the diagonal value. Okay. So if you're having here element means it is called diagonal matrix, the remaining all 0. So how to find the diagonal matrix? So we'll discuss the problem. The first problem, reduce the matrix A equal to -1, 3, -2, 4 to the diagonal form. So we have to make a diagonal form. Okay. So it is 2 cross 2 matrix means definitely we'll get here diagonal and the remaining will be 0. That is called diagonal matrix. So what is this value? It's our aim to find the procedure. First we have to find the characteristic equation. The characteristic equation, the formula is determinant of A minus lambda I equal to 0. So what is A? A is a given matrix and lambda I is a identity matrix. If it is given matrix is 2 by 2 matrix means the identity matrix is 1 0 0 1. So we have to substitute this one in this formula. We will get -1 minus lambda 3 minus 2 4 minus lambda equal to 0. The normal matrix multiplication we get -1 minus lambda into 4 minus lambda plus 6 equal to 0. Then simplify this one, we get lambda square minus 3 lambda plus 2 equal to 0. Then roots. So if you multiply two number, we get 2. Adding the two number, we get -3. So the value is -1 into -2. So the roots is lambda -1 and lambda -2 equal to 0. So lambda equal to 1 and lambda equal to 2. So there are two values. One is lambda equal to 1, another one is lambda equal to 2. Okay, so this is called eigenvalues. Next we have to find the eigenvector. So the form is A minus lambda I into x equal to 0. Now we have to consider A minus lambda I into x equal to 0. So this is 2 by 2 matrix. This is A modulus A minus lambda I and this is capital X. So X is denoted by number of unknown variables. So here 2 by 2 matrix means we will take two variables equal to 0. Now normal cross multiplication. So row by column, we'll get the first one plus column by row, we get this one. Okay, this is the first equation and this is the second equation we'll get. Okay, so simplify this one, we get my, okay, so we get the two equations. This is the first equation, this is the second equation. So before we got lambda values, so if lambda equal to 1 means what happened the first equation and the second equation. So we have to substitute lambda equal to 1 in this two equation. So that is minus 2x plus 3y equal to 0, or the second equation 2x equal to 3y, or x divided by 3 equal to y divided by 2. Okay. So we'll get 3 and 2. So x1 equal 3 and 2 is the transpose, is the given vector corresponding to lambda equal to 1. So this is the one vector. Okay. So this is the one vector. Next we have to find the second. So if lambda equal to 2 means what happened the equation. So minus 3x plus 3y equal to 0, or x equal to y, or x divided by 1 equal to y divided by 1. So this is the second eigenvector. So x2 equal to 1 comma 1 transpose is the eigenvector corresponding to lambda equal to 2. So if lambda equal to 1 means we get this vector, and if lambda equal to 2 means we get this vector. If you collect these two vector, that is called our new p vector. So x1, what is x1? X1 is 3 comma 2 transpose. Already I explained the transpose is nothing. If row by changing column, that is the normal. So this is transpose. So we have to change the form. So 3 2 and 3 1 and 2 1. So this is the p. So our aim is to find the diagonal matrix. The formula diagonal matrix is nothing. A p inverse a into p. Okay, so we got p value. Next we have to find p power minus 1, that is inverse p inverse. So p inverse formula is p inverse equal to adjoint of p divided by determinant of p. So what is the determinant of p? Determinant of p is 1. So 3 minus, okay, so that is equal to 1. So determinant of p equal to 1. So next we have to find the adjoint of p. Adjoint of p is nothing, just to interchange the diagonal element and replace the remaining one is the sign. Only replace the sign. If it is plus means minus, minus means plus. If interchange, we get 1, and this is one, you change the sign, we get the minus 1. If interchange, this is the, okay, this is the minus 2, change the symbol, and interchange this 2, so we get 3. So 1 minus 1 minus 2 3, that is a adjoint of p. So 1 minus 1 minus 2 3, this is the adjoint of 3. Okay, so this is the adjoint of 3, and after that p inverse, what is formula? P inverse equal to adjoint of p divided by 1. So 1 is a 1, so this is the adjoint of p, and as well as this is the p inverse. So p inverse equal to 1 minus 1 minus 2 p. And next p inverse into ap. What is p inverse? uh, Already we found p inverse. And what is a is the given matrix, and p is p also we got the first one. So this is the p is a 3 1 2 1. So 3 1 2 1. So next we have to multiply the normal multiplication. So first we have to simplify this two matrix. If you simplify this two matrix means the normal multiplication only. So minus 1, this is minus 1 plus 2, we get 1, and this 1 3 minus 4, we get minus 1, and here plus 2 minus 6 plus 2 minus 6, we get 4 minus 4. Next one, if you simplify this one, so minus 6 plus 12, so we get 6. And after that, so this two matrix multiply this, and next we have to multiply 3 1 2 1. So if you multiply this one, so row by column, and this one by row. So 3 minus 2, we get 1, and next one 1 minus 1, we get 0, and the next one 12 minus 12, we get 0, and next one minus 4 plus 6, we get 2. So this is called, this is the p inverse of a into p. Okay, so we get only the diagonal value. It is upper triangular matrix and also a lower triangular matrix. We get one the diagonal value. So this is called diagonal matrix. The diagonal value is 1 comma 2. Okay, so only we get the diagonal element. It is called diagonal matrix. A diagonal matrix is nothing, contains upper triangular matrix and also a lower triangular matrix. That is called a diagonal matrix. So this is the way of to finding the diagonal value. Okay. So thank you to all. I hope you all understand how to find the diagonal matrix. It's a working procedure is very simple, normal working procedure. Okay. So thank you once again. Thank you for watching videos.